Hello guys, so in this video we are going to discuss our question print maze path with jumps. So it's similar to the question that you might have solved in the past, get maze path with jumps. Still, if you haven't solved that question yet, I first suggest you to solve it and then come back to this video. So this time we just have to print our path with jumps. Okay, so let's understand our question. We are given a n cross m maze. We are standing in the top left corner and we have to reach bottom right corner. That's our destination. And in a move, we can go in three directions. One is horizontal, vertical, and diagonal. Also, there is no limit to the number of jumps you can make as long as you are inside the matrix. Okay, let's understand our question better. So let's take a matrix, a 2D array. Okay, so this is our 2D array. Okay, so let me make it for 4:4, where n is 4 and column is also 4, right? So here you go. Let me assign the row number and column number. So 0, 1, 2, 3, 0, 1, 2, 3. This matrix is 4 cross 4. Now, as it is mentioned in the question, initially we are standing in the top left corner. So we are standing here. So that's our source. Alright. And what our destination is? Our destination is bottom right corner. So this is our destination. Okay. So this is our source and this is our destination. So in destination, what's the row number and column number? So the row number is 0, 0 and column number is 0. So 0, 0. While in the destination, you got the last row and the last column. So I can say n minus 1 and m minus 1. Okay. So this is n cross m matrix, right? Okay. So now let's talk about the movement that is out to us. So we are allowed 3 movements. What are those 3 movements? One is horizontal. Okay. One is vertical. What else? And diagonal. Okay. So in the horizontal movement, we move rightwards, right? Rightwards. So let's see our horizontal movement. So if we are standing here and there is no constraint to the number of jumps, right? Let me write it here. Jumps. Okay. So there is no constraint to the number of jumps. So if I'm standing here, I can make 1 jump in the horizontal direction, or I can make 2 jump in the horizontal direction, or I can make 3 jump in the horizontal direction. As long as I'm inside the matrix, I can make the jumps. So what is happening in the jumps? My source column is increasing, right? My source column is increasing. Source column plus plus or source column plus. That means the source column is increasing. Okay. Now horizontal. So if now vertical. So in vertical, what is happening? My source row is increasing. Let's see. So if I make 1 jump, I reach here. If I make 2 jump, I reach here. And if I make 3 jump, I reach here. As long as you are inside the matrix, you can make the jump. So in the vertical, what is happening? Your source row is increasing. Now in the diagonal direction, both source row and source column is increasing, right? Both source row and source column is increasing. Let me the diagonal, right? And here when vertical we are moving downwards, right? So minion down. So in the diagonal, both source row and source column, they both are increasing. So let's see our diagonal movement. If we move by 1 jump, if we move diagonally 2 jumps, and if we move diagonally with 3 jumps, simply reach our destination. Okay. So Now we know the number of movements that is allowed to us. Okay. Okay, now what are we required? We are required to print the path. Let's see the path format. Okay. So for example, you are initially here 0, comma 0. You know, you can simply go to the destination if you make a diagonal jump of what? If you make a diagonal jump of 3. Right. So you will print D3. Or if you are here, you go horizontal, then you vertically. So that's how you have to print it. Let me see you. Like here for 3, comma 3, horizontal 1, vertical 1. 1 denotes number of jump you are taking and HVD denotes direction. Okay. So now I first recommend you to try it yourself. It's similar to the question that you just solved. Okay. That you just solved. Now let's talk more about it. Let's talk in the terms of faith and expectations. Okay. So I am standing here, my source. Okay. So my faith will be that I will take, for example, I will take H1, horizontal 1 jump, or you can say I will take H2, horizontal direction 2 jump, something like this. Or I will take vertical direction 1 jump, or let me drag it here, or vertical direction 2 jump. Okay, or diagonal direction 3 jump. As many as jump as you can take, as long as you are inside the matrix. So you will take 1 jump and rest the jump your recursive function will take care of. All right. So now that we know this much, okay, now that we know this much, let's try to code it. Okay. So let's code it. First, let's talk about the base case. Okay. Let me create the space first. Okay, perfect. So our base case. What is our base case? When are we getting our answer? So if here we are given source row, source column, destination row -1, destination column, that is n-1, this is n-1, and answer so far. So if our source row is equal to, destination row, right, and source column is equal to destination column, that means you are in your destination. So you will simply print your answer so far and return. Okay, perfect. So here, as you can see, you are given n-1. n-1, m-1 means last column of your last row. If you reach that, you are going to simply print. Okay, now the movements. So the first movement, horizontal, right? Horizontal movement. So for that, I will run a loop. I will run a jump loop for jump in range starting from 0 till what? Till, see, in horizontal, what is happening? We are moving rightwards, right? So my destination column. So 0 till destination column. And that's an important condition. If source column plus jump is less than or equal to destination column. If that's the case, then only I will call my recursive function. Then only I will make my recursion call my function, right? So paths with jumps. So here, source row will remain the same. In my source column, I will add jump and dr, dc. And in the answer so far, what I'm going to do in answer so far, first, as you can see, we are talking about the horizontal movement. So I'm going to add h, right? I'm going to add h, and then I have to add my jump, which jump I'm taking. So for that, first I'm going to convert it into string. And then add jump. Okay. So that's it for horizontal movement. Okay. So here we ran our loop from jump till destination column as we don't get out of our loop. So if we are here, right, we can only make jump till the last column. That is our destination column. And here we are checking only if our source column plus jump is less than equal to destination column. Only if it is inside the matrix. Then only we'll make the recursion call. Okay. Now let's see for for vertical movement. Okay, so vertical movement. So for loop will run till destination row this time. Perfect. And if source row plus jump is less than destination row, then only you will call your recursion. In a recursion, source row plus jump. Okay, this time your source row will increase. Source column will remain the same. In the answer so far, you will add V. V because vertical movement. Okay. So perfect for the vertical movement. Also, one more important thing. First, let's talk about diagonal movement. Then we are going to discuss it. Okay. So your diagonal movement. Okay. Then we are going to discuss that there is something wrong in our code that we will fix it. Right. Diagonal. So in the diagonal, what? In the diagonal movement, we can see source row as well as source column. Both are increasing. So I'm going to check if source row plus jump is less than equal to dr. Okay. And source column plus jump is less than equal to destination column. And we will run our loop till whatever is greater. Whatever is greater. It means max of destination row and destination column. Till then we will run our loop. Okay, and here we will increase both source, let me full screen, both source row and source column. We are going to add D. Okay, now first thing here, what I want to show you, that till how we are learning our loop. So we are running our loop from 0 to destination column, that is n minus 1. That is, we are running our loop. For example, here n is equal to 4. So we are running our loop from 0 to 3, right? But of course, we should run our loop from 0 to 4. As here, if we make a diagonal D4 movement, if we make a D4 movement, not 3 here, sorry. If we make a D4 movement, then we simply reach our destination. So what I'm going to do, I'm going to add 1 here. So TC plus 1. Here also, I'm going to add 1, destination row plus 1. Here also, I'm going to add 1. Because in the main function I passed n minus 1 and m minus 1. Okay, now what I want to show you, one important thing. Okay, you must be wondering that I have to add an invalid case here, that if my source row is negative or I get out of the matrix, then I will simply return. But there is no requirement to do so. Why? Because we are already taking care of it in our loop, right? We are only making the recursion call when it's a valid movement, right? So we need not to take care of the invalid base case. Okay, we need not to take care because we are already handling it. Perfect. Now let's try running our code. It's giving an error. Let's fix the error. Okay. Maximum recursion depth exceeded. Right. So here, always remember that we make one jump. There is nothing like zero jump, of course. So here it will be 1 because we start our loop from 1. Okay, because we make one jump initially. Okay, so we start our loop with 1. So that's our code and it should run this time. Let's try running it. Perfect, accepted. Let's submit it. Perfect. So this was our question.